Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
All right, so these are 3D shapes. 3D meaning that they have three dimensions or solids. Another name for 3D shapes are solid, 3D or solid. 3D shapes or solid, isn't it? 3D means they have three dimensions, usually length, breadth, and thickness or height. Three dimensions. 3D. For 2D shapes, it will just be a plain shape, like a rectangle, a triangle, a hexagon, a square. Those are 2D, only two dimensions, length and width, length and breadth. Can you get the difference? All right, I'm going to draw this and then you tell me whether it is a 3D or 2D. See what I just drew here? Good. So this is a 2D shape. It's a plane shape. 2D shapes are called plane shapes. What 3D shapes are solids. 2D shapes have only two dimensions, like a rectangle, a circle. Only two dimensions. That's 2D. All these ones, rectangles, squares, hexagon, trapezium, are 2D shapes, two dimensions. All right. I didn't hear you.
A hexagon is 2D shape.
Yes, a hexagon is a 2D shape because only two dimensions. Hexagon. Just two dimensions. Two dimensions. Let me see if I can squeeze in a hexagon. Maybe this shape might even have a hexagon, does it? Oh, it doesn't have a hexagon. Okay. I can draw one. I can draw one like this. Let me see if you can see what I drew here. I can zoom it in, maybe to 200 so that it can appear very well. At the bottom, let me scroll to it. Look at it here. What's the name of this shape? This one, a hexagon. Is it a 2D or a 3D? 2D. Just the dimension is 2, not 3. It's not a solid, it's a plane shape. In fact, 2D shapes are also called plane shapes. Okay? So another name for 2D shape is plane shapes. Plane shapes. But 3D shapes are solids, right? You can touch, feel it because it's a solid. That 2D shapes are plane shapes, only two dimensions. The D stands for dimension. But 3D shapes are solids. Anything that is in form of a solid is a 3D shape, three dimensions. You have thickness, height, width. Make sure I don't echo that echo is taken out. All right. And we looked at some of the 3D shapes. Of course, a sphere is a 3D shape because it's a solid. An ellipsoid. This is called an ellipsoid. Something like all this kind of rugby. Rugby football?
Yes.
Okay, this is of course a hemisphere. A hemisphere is just half of a sphere. Do you know a sphere cut into two?
It's a hemisphere.
It's a hemisphere. Then we call this torus. This thing that looks like You can think of it as this swimming float. How do I describe it? Have you practiced swimming before?
Yes.
You know this stuff you wear so that you don't drown. What is it called again?
I don't remember.
But you know what I'm talking about. This balloon kind of thing that you wrap around your waist, or so that you prevent you from drowning.
I don't remember.
Okay, now this is a cone. They are all 3D shapes. I just want you to take note of the names. Of course, you know what's this? You didn't get this, so this is not a cone. This is a cone. Is this one that is a cone? First of all, what is this? Let me circle it. You were the one that wrote this name. F. What's the proper name for F? Yes, F is a cylinder. So let's correct it. F is actually a cylinder. Oh, hold on, let me correct it. F is a cylinder. F is a cylinder, okay. Now, we call this G tetrahedron. Tetrahedron. We're going to name the number of sides and the number of faces and the number of vertices or corners. This one is a square-based pyramid. H is a square-based pyramid. Let me take it up a little bit. H is square-based pyramid. I is octagonal base. This should be octagonal base pyramid. You know why we call them octagonal base? Because the base is an octagon, isn't it? Octagonal base pyramid. All of them are pyramid. This is a pyramid. This is a pyramid. You can also call this a pyramid. Please, I'm echoing. I don't want to be hearing myself. Okay, so this is a pyramid, this is a pyramid. Now, you look at the base to describe the name of the pyramid. Like this is a square, so we call it square-based pyramid. And of course, this one is a hexagonal-based, octagonal-based pyramid because the base is an octagon. Now I said J is a wedge. All right. There's triangular pyramid, prism, not prism is just one M. Let me correct the spelling. Now this one that you may not be so familiar with is called an octahedron. That's L. You know M is a cube. And this one is a cuboid. Now you know this one is a pentagonal prism because the base is a pentagon, isn't it? 5 sides, 1, 2, 3, 4, 5. Pentagon has 5 sides. Anyway, we quickly look at all those shapes and their number of sides, plane shapes. This one is a hexagonal prism. I mean, Q is a hexagonal prism. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Hexagon 6. 1, 2, 3, 4, 5, 6. Hexagonal prism. And this one is dodecahedron. Dodecahedron. Some of them you may not need to bother about. This one is icosahedron. This one is pentagrammic prism. You don't have to bother yourself about all this. In fact, a pentagrammic prism is like a star. Can I stop echoing? A pentagrammic prism is like a star. All right, with this base is a star. Turn off anything that is making me to echo. Turn it off. All right, so that's that. Before we move away from this, I just want to say a few things about the 2D shapes. You know some of them already. Let me just mention them before we continue. 2D shapes and the different types. Let me zoom it to 200 so I can appear better. All right, 2D shapes are, of course, plane shapes. Can you give me examples?
Square, triangle,
Okay, let's start with the one with 3 sides.
triangle,
3 sides, triangle. 3 sides is triangle. 4 sides is what?
square,
4 sides is square. 5 sides is what? 5 sides is what? 5 sides is what? Pentagon. 6 sides is what? Hexagon. That's where we are getting all those hexagonal, pentagonal stuff. So 6 sides is hexagon. 7 sides is what? Heptagon. Heptagon. Let me write it better. Heptagon. Heptagon is 7 sides. Let me write a few more. You know octagon? You know octagon? Octagon is 8 sides. 8 side is octagon. Nine side is nonagon. And 10 sides is what?
decagon,
Decagon. Of course, these are plane shapes. These ones are plane shapes. Plane shapes. Or what we call 2D shapes. Two D shapes or plane shapes. You know that already. Please, you need to take note of them. Generally, we call them polygons. We call them what?
polygon,
Polygons. A polygon simply means many-sided shape, usually from 3 shapes and above. Polygon or many-sided shapes from 3 sides and above. Let me do this.
So my teacher said that octagons and hexagons are all 3D shapes.
No, they are 2D. Let me help you to explain it better. Octagons, hexagons, and what have you are 2D shapes, 2 dimensions. Now, you can get them in form of solids. Let's not mix it up. You know, a 2D shape has only 2 dimensions. 2D. Let me zoom it in a bit. 2D shape or plane shapes have only 2 dimensions. 2D shapes or plane shapes have only 2 dimensions. The 2 dimensions, what I mean by 2 dimensions is you're only going to be looking at how long it is and how wide it is. The length and the width. The length and the width. The length and the width. No thickness. Only 2 dimensions, length and width. How long it is and how wide it is. The length and the width. For plane shapes, there's no thickness. It's not thick, it's just plain, flat. Flat. Talking about how long and how wide. How long and how wide. 2 dimensions. Length, width, long, wide. 2 dimensions. So it's flat. 2D shapes are flat shapes. It does not have a thickness. So I can write it here. Let me show it here. 2D shapes do not have thickness. Have only 2 dimensions. That's why we call it 2D. 2 dimensions are length and width. The 2 dimensions will be the length and the width, how long it is and how wide it is. No thickness, but no thickness. No thickness. It's just how wide it is and how long it is, but no thickness. It's just about length and width. For instance, this place is the length. You can call here the length. And this one the width. It doesn't have thickness. So it's a flat shape. Flat, length and width. All 2D shapes, whether it's a hexagon or these polygons, have only 2 dimensions, length and width. But when you're talking about 3D shapes or solids, it has a thickness, so there will be 3 dimensions. By the way, 3D means 3 dimensions. Three dimensions. Or 3-dimensional shapes. 3-dimensional shapes are solids because it has a thickness. You can look at the length or the width and how thick it is. It has thickness, so you can feel it. It's a solid. All these are 3D shapes. 3D shapes: sphere, ellipsoid, hemisphere, cuboid. You can have a length, you can have a width, and you can have the thickness or the height. Length, width, thickness. There are 3 dimensions: length, width, and thickness, or length, width, and height. The 3 dimensions for 3D shapes or solid. 3 dimensions, which are length, B, width or breadth, if you like, and C, thickness or height, if you like. That's what makes 3D shapes different from 2D shapes. There's a thickness. It's thick. You can feel it. It's a solid. They are 3D shapes. We can talk about the length, the width, and the thickness. Let's look at this one: the length, the width, and how thick it is. Or the length, the width, and how thick it is. 3 dimensions: 1, 2, 3. I was trying to tell you that 2D shapes are different from 3D shapes, and I will explain it now. Watch this. I'm going to shade only this top. I'm going to shade it in green, in red. See what I'm shading here? Only this part that I shaded is what? What's the name of only this part I shaded? Yes, only this part I shaded is what?
Hexagon.
Good.
Hexagon.
Yes, the only thing I shaded is hexagon. This part I shaded is hexagon, and it's a 2D plane, only a plane shape. But when you have the rest, all of them, it is now a solid, and that's why we call this what? Hexagonal prism. And if you check out, a hexagonal prism has other faces. For instance, look at this face. Sorry, let me shade it in yellow so that you can see it better. Only this place I shaded in yellow is what? Pardon?
3D.
No, the place I shaded in yellow, only this part I shaded in yellow. What's the name of this shape I shaded in yellow only?
Hexagonal.
No, I mean the part I shaded in yellow. I'm talking about only where I shaded in yellow. Can you see where I shaded in yellow? What's the particular name for it? What I just shaded in yellow. Say that again.
Rectangle.
Rectangle. That is to tell you that a 3D shape has many faces of plane shapes. A three-dimensional shape or a solid 3D shape. 3D shape or solid. 3D shape or solid. We have a number of faces that would come together to form a solid. A number of plane shapes or a number of 2D shapes. In fact, for this hexagonal prism, you have two hexagons. Can we think about it very well? Let's think about it together. Let's think about it together. You know the top is a hexagon. Can you see the top I'm touching? The bottom is also a hexagon. And then of course you see the sides. The sides are rectangles. So you have many 2D shapes or faces, plane shapes that make up a 3D shape or solid. All right, so that's it. Can we look at the question you answered? I asked you to, let me see, let's start it from the beginning. Okay, I asked you to write the number of faces, the number of sides, and the number of vertices for each of those ones, isn't it? I hope you're still here.
Yes.
Now, the faces, of course, are the plane shapes that make up the 3D shape. For instance, let's this G, let's count it. 1, 2. You have a triangle here, another triangle here, then a triangle behind. So you are actually right. That's 4 faces. So I mark it for you. I will mark it in yellow or green rather. 4 faces. Let's look at the sides. Stay on the Jamboard. The sides we have 1, 2, 3, 4, 5, 6. I think that's all. 6 sides. That's correct. The sides are the edges. 1, 2, 3, 4, 5, 6. 6 edges. 1, 2, 3, 4, 5, 6. That's correct. 6 sides or 6 edges. Now the vertices or singular vertex are the corners. Let's look at the corners. 1, 2, 3, 4. Where did you get the other one? 1, 2, 3, 4. Only 4. 1, 2, 3, 4. Can you see what I'm counting? So how many vertices? Why am I echoing? How many vertices? 4. So this will actually be 4. It should be 4, not, it should be 4. So let's go to H. H, let's count the faces. 1, 2, 3, 4, 5. You're right. 1, 2, 3, 4, 5. You're right. 1, 2, 3, 4, 5. So we have 5 faces. Let's count the number of sides. 1, 2, 3, 4, 5, 6, 7. Let me count again. 1, 2, 3, 4, 5, 6, 7, and 1 on the other side. That's 8. You're right. There's 1 on opposite to this side, opposite to this place I'm striking. So 1, 2, 3, 4, 5, 6, 7, 8 on the other side. That's correct. Let's count the vertices. Vertices are the corners. I told you the vertices are the corners. The plural is vertices, singular is vertex. So let's count 1, 2, 3, 4, 5. That's correct. 5. You didn't do I.
No, I forgot to do I.
Okay, let me mark the ones you did first before we look at I. Let's go to J. J, faces. 1, 2, 3, and 4. You're right. There's 1 opposite to this one. 1, 2, 3, and 4. No, it's more. 1, 2, 3, 4, and there's 1 below it. 5. The base. The base is there. 1, 2, 3, 4, and then the base. Did you see it?
Yeah.
It's actually 5. 1, 2, 3, opposite it, and then the base 5. Let's see the sides. We have 1, 2, 3, 4, 5, 6, and 7 on the other side. Okay, no, there's it's more. 1, 2. Okay, this is how I'm going to do it so that it will help you to see it better. I'm going to draw out the hidden parts, those parts that are not exposed. Maybe it will help you to see it. I've made it very big, so I'm going to draw out the hidden parts. I'll show you what I mean by the hidden parts. There are some parts that are not exposed. So maybe when I draw it, you'll be able to see it better. Some of these parts are hidden, so I'll put them in dots. No, that's not how I'm going to do it. Can you see what I'm drawing here? Okay. All right. So, at least you can see some parts that are not exposed. So let's count it again now. The faces, first of all. 1, 2, 3, 4, 5. 5 faces. I can even decide to shade them differently so that you see it better. Let me shade this one in blue. I can shade this one in red. No, let me shade this one in red. These ones that are not so obvious, let me shade them in red so that you can see it. I don't know if you can see it, or can you? I hope you can. I hope you can. I really hope you can. Okay. So you can see some of those parts that are not hidden, that are not exposed. And that's why I said the number of faces are 1, 2, 3, 4, 5. 5 faces. Now let's count the number of sides or edges. 1, 2, 3, 4, 5, 6, 7, 8. Let me count again. Maybe I should be writing letters on it. 1, 2, 3. Let me write numbers on it so that you can see it. Oh, no. This one will come out fine. Let me use a black pen. This straight line 5. This one here 6. This one in green 6. The other one 7. This one in blue 8. This one 9. It's a lot too. This 10. One, two, three. Where did I skipped 4. Where is number 4? I skipped 4 when I was writing. Okay, so this one becomes 4. Are you seeing what I'm doing? So how many sides? If you saw what I did, how many sides? Please speak up. How many sides? 9 sides. 1, 2. You need to speak up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. Yeah. That's 9 sides. That's 9 sides. So it has 9 sides. That's what letter is this, by the way? Letter J. Letter J has 9 sides. Yeah, we say it has 5 faces. Let's confirm the faces. Face 1, face 2, face 3, face 4. We're going to face 1, face 2, face 3, face 4, and 5. Yeah, 5 faces. Let's confirm the sides. And I said there are 9 sides. 9, not 5. 9. It's actually 9. How about the vertices or the corners? Can we count the corners now? Are you ready for that? Are you ready?
Yes.
Okay, let's count the corners. I'm going to dot them. I'm going to dot them. The corners, or what we call vertices. The corners. Have we counted all? So how many? 1, 2, 3, 4, 5, 6. 6 vertices. Is that correct? 6 vertices. So that's J. J is actually 6. J is 6 vertices. So it's 6. It's 6 vertices. And many other ones. I will just do a few. Okay, let me see what you got for O. Let me see what you got for O. I won't do all. ML. You didn't do O, or did you? You didn't do O. Okay, I didn't give you O. Where's M? Let me see where I wrote M. I'll just mark a few of them. Okay, this is M. This M, which is a square pyramid or a cube. Let's go. How many for M? What did you write for the faces?
I wrote 6.
6. Okay, please let me just confirm with hidden details. I will just get the hidden details like this. No. Yes. So you got 6, 6. Okay, so let me confirm. So we have this 1, and the one opposite it 2, 3, and the one opposite it 4, 4, and then 5, and the one 6. So 6 faces, you are right. So M is 6 faces. Let me mark for you. M is 6 faces, that's correct. We'll soon be done. M is 6 faces. What did you write for the sides or the edges?
Right, I wrote 9.
Okay, let me count. I can even number it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's more. 11. It's more than 12. Did you just see it? Did you see it? I hope you can see what I've just counted. Has it shown at your end? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 sides. It's actually 12. M is 12. M is 12 sides, 12. What about the vertices or the corners? You wrote 8. Okay, let's confirm. The vertices, I'm going to shade them with green. 1, 2, 3, 4, 5, 6, 7, 8. I think you got this one. You got it. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. 8 is correct for M. A few more before we're done. You are getting it. Which one more can we? A few more can we do? Did I give you Q?
Yes.
How many faces for Q? What do you write for Q? Faces. Pardon?
8.
You wrote 8. Let me see. 1, 2, 3. There's also 3 on the other side. 1, 2, 3. That's 6. 1 down, another one up. That's 8. So you are right. 8 faces. 8 faces for Q. That's correct. You wrote 8. Let me write it properly. 8 is correct, so I'll mark it for you. What did you write for the sides? You wrote 11. Please speak up a bit. 1, 2. Okay, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it will be more. 11, 12, 13. There's still another one. 14, 15, 16. It's 16. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13. There's 14, 15, 16. It's 16. These 14, 15, 16 are the hidden details. Let me show you where I'm getting the hidden details. I will use a black pen to draw it. These hidden details here. Those ones that are hidden at the base. I don't know if you understand what I did. The base of it that is hidden on the other side. Do you understand? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can even write numbers on it for you to see. 1, 2, 3, okay, 3, 4, 5, 6. No, let me write the 6 up. 6, yeah. 7, 8, 9, 10, 11, 12, 13, then 14, 15, then 16. So there are 16 sides. Remember, that's for hexagonal prism. Stay on the Jamboard, please. That's for hexagonal prism. There are 16 sides. It's actually 16. 16 sides is 16. That's Q. Q is 16. So sometimes you may need to draw the hidden details to see it better. Now let's count the vertices. Let's count the vertices so that we can start rounding off. Are you ready for that now? What can I shade the vertices with? Let me use black. Black will be fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you see it? How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 vertices. So Q is 12. You wrote 10. Should be 12. Is it getting clearer now? It's getting clearer. Did you do K? Did I give you K? Yes, you did K. Can we mark K?
Oh, yes.
Let's mark K. Where's K? What do you write for K? How many faces?
I wrote 5.
5 faces. I think you might be right. 1 on the opposite side, 2, 3 on the opposite side, 4, then 5 at the base. That's why it is called a triangular prism. A prism is a solid with a uniform cross-sectional area, you know. When you cut through, everything will be the same. In fact, this is how we know a prism. The two ends from one face to the other face will look the same way and will be of exactly the same shape and same size. If you have a triangle here, on the other side you also have a triangle. So it's called a prism. When you have something, one shape here, and the other face, opposite end, is also the same shape and the same size. It's a prism. If you look at Q, we have a hexagon at the top. The opposite face at the bottom is also a hexagon. Is it 1, 2, 3, 4, 5, 6? Okay, so that's why it's called a hexagonal prism. So a prism, we have the same shapes of the same size for the opposite ends. Opposite ends. Look at this. F. Can you see F?
Yes.
You see at the top, what's the name of the shape at the top? For F. What's the name of the shape at the top for F? Tell me quickly. Let's. What?
For F is circle.
Circle. So, and it's also a prism now, do you know? Because what you have at the top is also what you have at the bottom. So if we, another name for cylinder will be what? If you wanted to describe cylinder as a prism, how will you describe it? this is what I mean. You call this one triangular prism because the shape of the ends are triangle. The shape for both ends, for those two ends that have the same shape and the same size, is a triangle, and so you call it triangular prism. Now, what will you call this F? If you're going to call this F, yeah, this F is this F.
Cylinder.
Yeah, it's a cylinder. What do you think would be another name for it if you wanted to also name it like a prism?
True. What did you say?
You will say, because the cross section, the ends, what you have at the ends, maybe I could shade it for you to see the end, the ends, the opposite faces. Opposite faces is what you have with the opposite faces. It's a circle now, isn't it?
Yes.
So we can call it circular prism. Is it not?
Yes.
So a cylinder is a circular prism, or circular prism if you like. Does it make sense?
Yes.
It's a circular prism because the opposite ends that are the same is a circle. Just like the opposite ends for this one is a triangle. Okay, I think what I would have just done is to draw the hidden detail for this one so that you see it. If I had drawn the hidden detail, you would have seen that this is what you would have had. And then you would have had this. So you see that the opposite, no, I didn't, that shape is not properly drawn. Let me see if I can draw it better. Let me draw it better. Okay, I think it's better here. And this. All right, so that if you look, you know, the thing about this is if you're not careful, you'll be able to identify this very well. These are just the hidden details. All right. So this is a triangular prism because the opposite ends are triangles. So you've given me 5 faces. Now, what did you give me for the sides, for the edges? So 5 is correct for K. I will mark it. 5 is correct for K. We're going to stop with this one. 5 is correct for K. What do you give me for the edges or the sides? Quickly for K. Let's go so that we are ending with this particular one. You have done very well. Yeah, for K.
Okay. I did 5 faces.
5 faces. How about edges or sides?
B.
How many did you give? 6, right?
I did
What did you write for the sides?
in K
Yes.
5.
You wrote 5 faces. Okay, let me count the number of sides now. I'm going to use letters. We have 1, 2, 3.
I wrote 6 for sides and 5 for faces.
Faces. Okay, let me count the sides now to be sure. 1, 2, 3, 4, 5, 6. We have 7. We have 8. We even have 9. You should be careful when you're counting this. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are nine sides or 9 edges. Can you see it now?
Yeah.
If you draw out the hidden details, it will be easier for you to identify. So there are actually 9 sides. There are 9 sides. Okay, so let's just finish up. 9 sides. So how many vertices? How many vertices? Vertices 1, 2, 3, 4, 5, and then 6 here. There's a 6th one here. 1, 2, 3, 4, 5, No, 1, 2, 3, 4, 5, 6. Yes, 6 vertices. 9 sides and 6 vertices for K. 9 sides and 6 vertices for K. There are actually 9 sides. 9 sides and 6 vertices for K. 9 sides and 6 vertices. Alright, I think that's clear. Is that clear? Alright, okay. So this is a summary of the three-dimensional shapes or 3D shapes of solids, the number of faces, the number of sides or edges, and the number of vertices or corners. Remember, the vertices are the corners, like the corners, all these corners are the vertices, or these corners are the vertices. The plural is vertices, singular is vertex or corners. Now the sides are the edges, 1, 2, 3, all the edges, are sides. Now faces are all the plane shapes that make up the solid. The faces will give you the number of plane shapes that make it up. For instance, we were able to discover that for this cube, we have, if this is a cube, we have how many faces? 1, 2, 3, 4, 5, 6. 6 faces, and each face is a cube itself. Or even for the cuboid, we also have 6 faces. 6 faces. That's that for 3D shapes and 2D shapes. And of course, we talked about the polygons, their names. For 3 sides triangle, 4 sides square. No, 4 side is not square. I need to correct this. 4 side is called a quadrilateral. The general name is quadrilateral. A square is an example of a quadrilateral. The general name is quadrilateral. Quadrilateral cube. 5 sides is pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon. The general name for 4 sides is quadrilateral. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.